Welcome to clickmyproject.com. Here's the title of our product: Modeling Urban Behavior by Mining Geotagged Social Data. Here is the abstract of our product. We made use of the probabilistic model to reveal how venues are distributed in cities in terms of several features. To fit our model to a large dataset of more than 11 million check-ins in two major cities, New York and Tokyo. We aim to automatically discover decomposition of the city into overlapping regions, such that one region is possibly associated with shopping centers that are active in the morning, while other is associated with the dining venues that are active in the evening. First, we have calculated the probability distribution of a single feature. Conditioned on the location in the city, we construct a model to highlight what feature values are most likely and distinct at different locations within the city. Second, we have described a principal approach to quantify the importance of the different values within the trained models. After focusing on the various regions of the single city, our next process is by using the extracted model instances to find most two similar regions between two similar cities by spatial distribution. Finally, we provide a similar output and show that our regions are both consistent with the data in terms of predictive performance. Here's the flow diagram of our product. First, we get the Foursquare data. We have taken a large data set of more than 11 million check-ins in two major cities, that is New York and Tokyo. The content information of the particular data set, such as user ID, venue category name, lateral, longitude, and has been widely adopted for user activities. For finding the user activities, we explored both future values and user interest for feature analysis from the new perspective, and propose a novel location prediction framework based on spatial distribution. Next is we are, after loading the data into the database, we are processing the pre-processing the data that are many outliers, that is the unwanted data in our collected data, that is just the poor positioning signals of the devices used to track the trajectory in the urban areas. According to the analysis, most of our outliers were collected inside the buildings where signal is lost. Before we start our process, the raw data should be pre-processed to remove the outliers. Next is the feature analysis. We describe a principal approach to quantify the importance of different features within the trained models, whereas all the features contributed. We discovered that the most defining feature for the components uncovered by the model is visitors by the venues. This finding suggests that further analysis of the user behavior is promising direction for extracting additional insight. Regions are only one subdivision of the city. Another one of the points of interest, which are locations where the user activity shows some specific locations. Next is the finding similar regions and similarity score. After focusing on the various regions of the single city, we use the extracted model instances to find most two similar regions between the two cities, a task which was previously attempted with the heuristic approach. This time, we also benefit the solid theoretical grounds of probabilistic models to define the principal measure of similarity, and we describe a procedure to greedily find two regions maximizing measure. This has been done by the comparison the spatial distribution of human hotspots using call data, the distribution of venues category of various scales, and by building the network of the city by urban residents, mobility flow, and computing centrality measures. Next, finally, is the geotagged data. We also benefit the greedily find two regions maximizing measure. Based on the matching process with analytical evidence and we compare our approach with previous that provides similar output and show that our regions are both consistent with the data and sharply defined characteristics, meaningly they are easier to distinguish from one another. Finally, we define the empirical performance solely present the urban activity contained within the Foursquare database. Based on the geotagged data, we found the empirical performance. So this is the running procedure of our product. First, right click on index page and choose run file option. Click next and choose get data for New York City, and then load the data into the database. and the data loaded is successfully here, and then click next. Choose second dataset, that is Tokyo City dataset, and then click load data. Later loaded successfully here, and then click next. Pre-process the data, New York City data, click OK, and then click view data, and then choose next, and the Tokyo dataset, choose pre-process, click view data, and select city, get the future values based on the time visited by the user. It will show the result. Refresh the table and then choose Tokyo City and choose feature values. Then we will find the user interest here. Load the city, choose any of the city, and choose user ID and click the user interest. Based on the user interest, it will show the interest, and then choose Tokyo City. Choose any of the user ID. We'll get the user ID here, and then click next. This is the spatial distribution of hotspot, and we'll find the similarity score here. This is the hotspot of New York City, and this is the hotspot for Tokyo City. We'll find the similar regions in both of the city here, and this is the similarity score, and then click next. This is the geotagged data. Choose any of the data and choose the okay. This is the location based on the latitude and longitude, and then click next. This is the geotagged data for Tokyo City. And this is the location for the latitude and longitude. Okay. And now the process over. Thank you for watching.